guys, so final problem, but this is no slouch of a problem. So number 13. A plane is flying 620 miles per hour on a course, here it comes, 58 degrees north of east. So if I take that and convert it to what we learned in class, we've got this drawing right here where the plane is 58 degrees north of east. So we've got that 58-degree angle right in there. Then a wind is blowing, so assuming the airplane's right here, 99 miles per hour, blowing, sorry you guys, 22 degrees north of east. So, assuming that this is my now northerly direction, it's going to be 22 degrees north of east. So that little sliver right there is 22 degrees. Now, they're going to ask us some questions about this situation. Draw vectors representing the plane and the wind. So here's the plane, here's the wind. Check. What is the resulting speed of the plane? Now this gets a little tricky. So what they're going to want us to do is the resulting speed of the plane, if we connect these vectors, because these vectors have an effect on each other, the wind is affecting the plane, so the resulting speed will be this length. Now this gets a little tricky, but if I take this line out and I extend a line right here, this is 90. 90 plus 58 is 148. Now why am I finding that? Because if I subtract that from 180, I'm going to get 32. This is a lot of geometry here. So that's 32. This right here is 90. So the whole angle right here, 90 plus 32 is 122, plus 22 is 144. So this angle right here is 144. So now I'm going to redraw this back in here. And remember, the airplane is going 620 miles per hour. So that represents the magnitude of the airplane's vector. These are not to scale. And then the 99 mile per hour is right here. So that's that magnitude right here. So the problem is asking, part B, what is the resulting speed? We have to find the distance here, which is the magnitude. There's only one way to do that, and that is the law of cosine. So I'm going to just randomly label my triangle with A, B, C. Now we know that angle B is 144. We know side C is 99, and we know side A is 620. So I'm going to use the formula that involves angle B, and that would be B squared equals A squared plus C squared minus 2AC cosine of angle B. And there's enough there, sorry you guys, there's enough there to fill in and find side B. It's going to be a lot of work, but we can do it. B squared equals A squared, which is 620 squared, plus C squared, which is 99 squared, minus 2 times A, 620, get rid of this, 620 times C, which is 99 cosine of angle B, which we discovered was 144 degrees with a lot of geometry. I'm going to figure this stuff out and get back to you in 2 seconds. Okay, just to fill in some missing pieces, I just squared this, then I multiplied all that out. Now somebody who's observant might think I made a mistake because I went from a minus to a plus, but cosine of 144 is negative. So I'd end up getting this, so let me pause this one more time. Okay, and you can see I added it all together. B squared equals that crazy mess, so we're going to take the square root of both sides. So here we go. I'll do this live. 14,755.9, enter. 380, so B is 384. Hold on, something went wrong. Uh-oh. Okay, so just going to be honest with you, because that's part of math. I was going to get 300 and something, which I know can't be true because he's going 620. I mean, this has to be a lot bigger than that because we're getting help with almost a tailwind. So I went back and looked at my work, and here's my mistake. This needed to have another 0 right there. So let me get back to you in just 2 seconds. All right, now we got her back on track. So I added this to this to this, and I got this. Take the square root, and I've already done it. And that is 702.5 miles per hour. So that's the length of that vector, 702.5 miles per hour. That's the resulting speed. Now the resulting direction is kind of interesting. And here's why. The resulting direction is going to be, the only way we're going to be able to figure that out, let me pause it. There's an announcement. Okay, back to what I was saying. So, what is the direction of the plane? So, what we need to do, you see this right here is 58. But that is 58 degrees north of east. So what we need to do is now calculate this. So that should help us formulate a plan. We need to figure out angle C and then subtract it from 58, and that will help us understand this right here. So how are we going to do that? Well, law of sine is going to come to our rescue. So we're going to go sine of angle C, that's this green angle, over side C, and then we can pick this one, sine of 144, all over the new speed we found, and just use the law of sine. So we multiply that way, we get 702.5 sine of C equals, now we're going to cross multiply that way, but first we got to find sine of 144 and then multiply that by 99, 58.19. Now I'm going to divide by 702.5, divide by 702.5, and I get sine of angle C, here we go, 8, should have just 0.19 divided by 702.5, 0.082. But now we got to go second sine, 0.082. It's going to spit out a little tiny degree measure, so angle C is 4.7. So the wind is knocking the plane off its path by 4.7 degrees. That's what this is right here. So to figure this out, we got to go 58 minus 4.7, which we can do that in our head. It's 53.3 degrees north of east. So that's the answer to letter C. And the last one's just some real low-hanging fruit. After 6 hours, how far has the plane traveled? Well, 702 times 6. So 702.5 times 6. 4,215 miles. That is a math problem, ladies and gentlemen. That's a great problem to finish this trimester on. Congratulations, but you guys got this.